back. Okay, let's rock and roll. We're doing lesson 2. Solving absolute value equations. I'll quickly show you what it looks like graphically. We are in pre-calc, so we'll be doing it algebraically, unfortunately, for the most part. But I want to show you what happens graphically, okay, if you ever use some graphing technology. Okay, so what do we got here? Here is a graph of y equals the absolute value of 2x. Okay, and we are solving this equation here. So we got 4 equals the absolute value of 2x. So the V shape is my graph. When you're solving an equation that looks like this, there's actually 2 lines happening. So there's the absolute value line, and then there's the line y equals 4 right here. Okay? And the solution to this equation is simply where those 2 graphs intersect. Okay, so the point 2, 4 and negative 2, 4 is where you find your solutions. So graphically, if you're solving one of these, you can just graph both graphs, and then you can click on the intersections and you can see your answers. Okay, so if I was listing the answers, I would simply say, well, the answers are x equal 2 and x equal negative 2. And if I wanted to know the coordinate, I would just go plug it into here and figure out what the y coordinate is. Okay? So that's just what it says down here. You can get the y values by substituting in the x values. All right? So that's basically what's going on graphically. If it's a parabola, I can show you one of those too. Well, here's another one. So solve by graphing and verify the solution. Again, we're never really gonna do this. Maybe it comes up in a multiple choice, or I might give you a graph and say what are the solutions here. But yeah, if you were solving this one, then there's 2 equations. 2 equations. You got y equals absolute value of 2x minus 4. So I suppose you could sketch that one. And then you're going to sketch what it's equal to, y equals 2. Okay, and if you do it on grid paper, you'd be able to actually go find the intersections pretty easily without doing any heavy math. Unless I gave you some tricky equations. But there's y equal 2. There's the absolute value graph. There's my 2 solutions. So I got x equal 1. I'm just looking at that coordinate, and x equal 3. Now, because I can read it off the graph, I can see what the y value is. It's going to be y equal 2. That makes sense, right? Because that's my horizontal line. But it's just that easy doing it graphically. Okay? Now, again, we're doing pre-calc, so we will do this without sketching the graph. We'll solve it algebraically. Okay? But do you guys sort of understand what's happening in the background, I guess? Right, like you can now visualize, well, oh, what does it mean when I'm solving this? Well, I have these 2 graphs and I'm looking for the intersection points, okay? I'll show you what it looks like for a parabola. Eventually we'll solve these ones algebraically as well. Today I think we're just focusing on lines. Okay, so it says consider this. So it's the absolute value of some parabola equaling 4. Okay, here's my graph for my graphing calculator. So here's the parabola. I'm not going to sketch it because my marker's not very good. And then here's the line y equal 4. How many solutions do you guys see visually? 4. Okay, so with a parabola, when we cover that, we'll realize, hey, could there be less than 4 solutions? Just like if you're just thinking, like, is it possible to have less than 4? Yeah? Like if I just move this line up a bit and did some y value up here and only get 2. Would it be possible to get 3? Yeah. Yeah, if you drew it just so that you just touched that, which used to be the vertex, you could get 1, 2, 3 solutions. Could I get 0? Yeah. Well, yeah, below, like if I just said, hey, y equals negative 1, right, you get 0 solutions. And that makes sense conceptually as well, because absolute values will never equal a negative number, right? So if I just set y equal to a negative number, then obviously I'd have no solutions. Wouldn't be possible. Okay? So right here, this one we use the graphing calculator to get the solutions. So I see like 0.4, 4.6. So that would be a lot trickier to get on just an XY grid, right? Like this is one where you'd want to solve it with graphing technology or do it algebraically. The nice thing about algebraically is if you get weird numbers like this, it's easy to find them.
Ms. Garten, please call the office.
All right. So now you know what it looks like if it's a line, if it's a linear graph, and you sort of know what it looks like if it's a quadratic graph. All right. So now that you know that, we're basically just going to go and start solving them algebraically. So let's see. This is the same question. We're not going to do it. It's the exact same question. So without a calculator, graphing takes time and precision, and we don't got time for that. We ain't got no time for that. So we're going to use algebra as our main method to solve. And we'll do just a little bit of practice here. So this is where we actually use the definition of an absolute value. Okay, so there's two things that can happen. So remember, the definition was this, right? The absolute value of x is negative x if x is less than 0. Otherwise, it's positive x if x is greater than or equal to 0. So when you're solving these things, you actually get rid of the absolute value and you solve two equations. So there's two equations you're going to solve. And I'm just going to write the positive one and then the negative one. So our first equation is you take the absolute value and you set it equal to whatever this is but positive. So it's already positive, so I'm going to solve that equation. And if I solve this one, I get x equal 10. And now let's check. If I go plug 10 in here, is the absolute value of 10 minus 3, is that equal to 7? What do you guys think? You get 7 here, absolute value 7. You get 7 equals 7. So that works? Yeah? But is there another possible number that could work? Well, that's where the negative equation comes in. So right here, if I take my absolute value and I get rid of it, another possibility is, well, if that equals negative 7, and I know I said absolute values can equal negative numbers, but there is no absolute value here. But if this was negative 7, wouldn't the absolute value just get rid of it? Right? So that's why we're saying, hey, when is the inside quantity equal to negative 7? So when does that happen? Well, x would have to equal negative 10. Let's check. So does it actually work? If you plug in negative 10, oh, did I make a mistake? Oh, sorry, I did make a mistake. It should have been right. Oh no, that was fine. This is what I'll fix it. My bad, my bad. Nah, this way you guys will never forget. So negative 7. I'm going to add 3 to both sides. So sorry, you get x equal negative 4. My mistake. So now if I go plug in negative 4 here, it doesn't work. We'll go negative 4 subtract 3. Does that equal positive 7? So let's see. I get the absolute value of negative 7 in here. And that is 7. So negative 4 also works. Okay? The only way you're going to get your two answers is by taking your absolute value, the quantity inside, setting it equal to the positive version, that's one of your answers, and then saying, hey, well, if this quantity is negative, the absolute value would get rid of it, so you're going to take this and set it equal to negative whatever's on that side. Okay? Alright, alright, alright. Let's do another one. Does anybody have questions before we look at number 2? I'm just going to clear the screen as well, just to make it easier. I think there's going to be too much writing on this slide. So give me a moment. Clear ink from page. Okay. So let's do number 2. So you're going to solve two equations for number 2. You're going to solve 2 minus x, so whatever's inside the absolute value, equal to positive 3. That's one equation. And then we're also going to solve whatever is inside the absolute value equals negative 3. Because no matter what, the absolute value will make this positive. This one's already positive, so we're okay. So I'm just going to what? Subtract x from both sides and subtract 3. So be very careful. I think I get negative 1 equals x. Do you guys agree? Okay. So that's one solution. And then over here, I'm going to subtract x from both sides and add 3. So I'm going to get 5 equal x. Just double check my work. Am I okay there? Now, quickly double check. If you plug in negative 1 here, you get 2 subtract negative 1. So you get absolute value of 3 equals 3. Is that true? Yeah? And if you plug in 5, you would get 2 minus 5. So you get absolute value of negative 3. And that equals 3 when you do the absolute value, correct? Perfect. So you should always check solutions though. When you have absolute values involved, you probably want to check your solutions. Okay? Okay, let's take a look at something a bit more complicated like number 3. Giving you a little warning here. Absolute values can't equal a negative value, so that's for number 4. I'm dragging the whole thing with me. Oh gosh, it's gonna get rid of it. There. Okay. All right. Okay, so here's number 3. We're gonna solve this one. If it's not just absolute value equals a number, you need to isolate the abs before solving, okay? And you need to isolate your absolute value before solving. Otherwise, our method won't work, okay? So as long as, if a number is outside an absolute value, it's multiplying the absolute value. So we'll simply divide this side by 4, divide that side by 4, and now we have absolute value of 3x minus 2 equaling 4. Okay, and then we'll solve our 2 equations. So we'll solve the positive version. So equation 1, 3x minus 2 equals 4. And then the second version would be taking the whatever inside the absolute value, setting it equal to whatever's on that side but negative. Alright? So I'll go solve this one. I'll add 2 to both sides. Then I'll divide by 3. So I'll get x equal 2. And you should double check. Like if you go back to the original, you get 6 minus 2, which is 4. Absolute value of 4 is 4. So this works. And now we'll go solve this one. So we'll add 2 to both sides, which will give us negative 2 over here. So we'll get negative 2/3. When you plug in negative 2/3, 3 times negative 2/3 is negative 2. Negative 2 subtract 2 is negative 4. Absolute value of negative 4 is 4. Do we agree? Yay! Alright. Alright. Okay, this was number 4. And now, just looking at that equation, I hope some alarm bells are going off. What's maybe wrong with this? Yeah, you got an absolute value equaling a negative number. It can happen. If that was negative, is that negative? No. So what you want to do, just to make sure, is you isolate your absolute value. So if you divide both sides by 4, then you'll have a clearer picture, because now I have absolute value of that equals negative 4. Well, there's nothing but an absolute value on this side. An absolute value will never equal a negative number. So there's no solutions for that one. So what's this telling you? It's telling you that if you were to graph this, your line, y equal negative 4, would not be touching the graph of that. Right? Because this graph will be completely above, it'll be completely above the y-axis, and the other line's down here. So they never touch, so there's no solutions. Okay? Alright. How do you guys feel about this? Good? That's basically the lesson. Like, we'll do a bunch more, but if you get that, that's the gist of it. You're solving one of these. Strategy is isolate the abs, and then solve your 2 equations. One the positive version, and then one the negative version. You only need to make one side negative, so I'd always pick the easiest side. Okay? Let's do one that involves a binomial. Okay? And just a reminder that you need to verify your answers. Sometimes you'll get like extraneous roots, but so you always need to verify. Okay? Because sometimes you'll get an answer that just doesn't work. It can happen. Okay. So, is there anything on this side that I need to get rid of, or is the absolute value isolated? It's isolated. Okay, so maybe before we start, we should write the steps. So steps. This is a strategy for every question. Isolate abs. Step 2. Solve positive equation. And I'll just write no abs, right? Like you're dropping the absolute value and you're solving the positive equation. And then you're going to solve negative equation. And in brackets I'll put make one side negative. It's got to be the same side that you kept positive over there, okay? So what I mean over here, I'll just give you a moment to write that down actually. Okay, so for the positive equation, we'll drop the absolute value, and I'm going to write it on this side. So I drop the absolute value, and this is already positive, so there we go. So I'm going to solve that one. Let's do it. Let's solve it right now. So subtract x from both sides, and then subtract 6 from both sides. So 8 minus 6 is 2. So here I get x equals 2/3. And then we check, because you always have to check. So unfortunately, we're gonna go back here and we'll check it. If you have a calculator, it makes your life easier. Actually, can you guys check really quick on a calculator? So if I go 2/3 plus, this would be what, 24 over 3? I'm trying to go fast and get my common denominators really quick. I'm gonna get 8/3 over here, plus 18 over 3. So my word, what do I get? I get 26 over 3 equals 26 over 3. Do we agree?
Yep.
Okay. By the way, would it be unreasonable of me to ask you to do that without a calculator?
No.
It would definitely not be. Right, it's just basic common denominators from grade 7 or 8, so that's good. Okay, so that one works. Any questions about doing the positive branch before we do the negative one?
No.
Okay, for the negative one, so again, I'm going to take whatever my absolute value is. So 4x plus 6 equals, so on the last examples, we were able just to go negative and then whatever was on the other side. This is a binomial though, so what do I need to remember to do? Times the whole thing. So better use some brackets and go negative whatever that is, okay? So if it's just a monomial, you can just go negative monomial, right? Because it's going to apply to the whole thing. If it's a binomial or bigger, you need brackets because you need to distribute the negative inside. And that's the step that a lot of people forget. Okay, so do lots of practice and don't mess that up. So here we go. We'll distribute the negative inside. So I'm going to recopy this side. I'm going to get negative x subtract 8. And now you can solve that equation. So I'll add x to both sides, and I'll get 5x. I'll subtract 6 from both sides. Negative 8 subtract 6 is negative 14. And I get another disgusting looking number. I get negative 14 over 5. And then we just want to go back to the original absolute value equation and check it. So I'm going to be doing my my common denominators as I go. So I'm plugging in for x. So I get negative 14 over 5. And I'm going to put this one as something over 5. So multiplying it by 5 over 5 so that I get 40 over 5 equals absolute value of 4 times 14 is, what's 4 times 4? 16. So what, 56? I get negative 56 over 5. And then plus 6, I need it to be over 5, so that's 30 over 5. All right, let's see. Sorry, I'm kind of going this way. This is going to be, what is it, 26 over 5 on the left-hand side? I think I got that. And then negative 56 plus 30 is going to be negative 26 over 5. Do the absolute value. It works. So both answers work. All right. Any questions on that one? Everyone's okay? Alrighty. Just another one, a little bit harder. Because now, so solving this one algebraically, my absolute value is not isolated, so that's going to be my first step. So in every question, like you're going to be going back, and like this is your algorithm, okay? So it's these 3 steps. Isolate the abs if it needs, solve the positive equation, solve the negative equation, and I suppose I should have added like don't forget to check solutions, right? So to me, it seems like if I do those 4 steps every time, and I can do basic algebra, then I should be fine. It's a matter of remembering, I guess. All right, so let's isolate right away. So we'll just divide both sides by 2. So I'm going to get absolute value of 3x plus 1 over here. And I wonder, if I'm going to divide, this binomial by 2, I need to do what? Divide 2x by 2 and also the 8, right? If I couldn't do it to both terms, then I'd be leaving it like a rational expression like that, okay? But because I can go 2x divided by 2, that's just x, and then I can recopy the negative sign, and 8 divided by 2 is 4, then it's okay to write it like that, right? I guess another way of thinking about it is you could pull out the greatest common factor. So that would, if you pull out the 2, then you have x minus 4 divided by 2. This 2 is multiplying everything, so 2 divided by 2 is 1, and you get the x minus 4. Alright? Was that our last unit? Like doing that? That was our last unit, right? Rational expressions? Yeah, that was our last unit. Okay. So we're now in a unit where we're basically using a lot of the knowledge we learned in this course, right? Like we're using quadratics. You're using like your grade 10 knowledge to draw lines. You got rational expressions all over the place. You got equations. All right. So 2 equations. Now that we have this, I'm going to just go over here and say, here's my first equation. So drop the absolute value. Set it equal to just whatever you have here. So if it's x minus 4, it's x minus 4. Your other equation, your negative equation, is take the absolute value. And what do I need to not forget? I go negative.
-1 bracket.
Use brackets. There. Try not to do too much at once. Just do that. Because then if I'm looking at your work, I'm like, okay, they clearly got that concept. Okay? Let's solve the positive one first. So subtract x from both sides. You get 2x. Subtract 1 from both sides. You get -5. You get x equals -5 over 2. I don't know, I like to just wrap up one branch all at once. So let's go check. So I'm plugging into here. So I'm going to do a little bit in my head. So I'm going to have 3 times 5 over 2. So I'm going to get -15 over 2. And then it's plus 1. I'm going to write it as something over 2. So plus 2 over 2 equals, that was it, x minus 4. So x is -5 over 2. I need to write the 4 as something over 2. So it's 8 over 2. There. So let's see, in here, I get -13 over 2, apply the absolute value, get positive 13 over 2. And does that equal this? I get -13 over 2 here. Are they equal? Are they? No. So what does that mean? Is this a solution? No. So I'll just write x equal -5 over 2 is not a solution. Doesn't work. So if this was grade 12, all you need to do to indicate that that's not a solution is that. Just cross it off. They're not necessarily interested in seeing the check unless they specifically ask for it. So it's just understood, like, you show your work solving it, and then if you cross it off, it means that for some reason you understand it's not a solution, okay? But this is why, because we checked it. All right, let's try the other side. Does anybody have questions? I just hear some chatter, so is everyone good? Okay, so we'll solve the other side. We'll distribute the negative into the brackets first. I'm going to try to write straight. So basically all the signs flip, and I'm going to add x to both sides, so now I get 4x. I'm going to subtract 1 from both sides, so 4 minus 1 is 3. So I get x equal 3/4, and then I'm going to check. I mean, if you have a calculator, great. I'm just thinking you might not. So I'm plugging into the absolute value. 3 times 3 is 9, so I get 9/4 plus 1. So I'm going to write it as 4 over 4. And then here, remember, going back to the original, so you get 3/4. subtract 4, but I need to multiply it by 4 over 4, so it's 16 over 4. Okay, so inside the absolute value, again, you get 13 over 4. When you do the absolute value, that's what you get. Over here, though, you get negative 13 over 4. So that doesn't work. So that means that this is not a solution, so you can just cross it off. When you cross it off, make sure it's still legible, like you can still see what it was. But so, final answer, there's no solutions. What does it mean? It means that these two graphs never touch. You guys want to see? You can quickly sketch it up on Desmos and just confirm, like visually. You can try. Again, this would not be expected of you, obviously, but just so we can see what's happening. So how do we get absolute value on this? Let's see. I think I can do this. There's 3x plus 1. Okay, so there's the absolute value of the line. And now we will graph, what's the other one? 2x minus 8. Okay, so there's the two lines. Do they ever touch? No. And if you zoom out, you can imagine they'll never touch. It's starting to look like they touch, but they're not. Zoom in, no touching. Hello? Someone said,
Can I see your note?
My notes? Yeah.
Shouldn't it be plus 6 over 3 or plus 6?
Which side are you on this one?
Yeah.
Over here?
Negative x plus 4.
Oh, I suppose so. Yeah, did I make a mistake on my check? The original is x minus 4 though. So I'm plugging in x, so x minus 16. Yeah, no, it's still negative. Yeah. You had me scared there. Even if it was positive, we still wouldn't get a solution, but yeah. No, it's x minus 4, so definitely got a minus in there. Any other questions? Next slide. Okay, good. This is about as bad as it can get. What if you have an absolute value on both sides? Okay, so it turns out that if you have an absolute value on both sides, you still just pick a side, so you can drop all the absolute values. You pick a side to make positive and negative. Because technically you got to make them both positive and negative. But when you look at all the equations, you're going to get a bunch of duplicate equations. And it just works out that you still just pick a side, make it positive, make it negative, and solve. Okay, so I guess I'll write that down. Pick a side. So you're still just going to solve two equations. Two equations, whatever. My shorthand for equations, EQN apostrophe S. So I'm just going to arbitrarily decide. I usually just do the right side. So I'm going to drop the absolute values for the first one. I'm going to solve that one. And then for my second equation, the one that's negative, I'm choosing this side. So I'm just going to go open a bracket, 2x minus 7, and I've made it negative. There. And remember, why are we doing this? Because it's our definition of an absolute value. Like if this quantity is positive, then that quantity is positive, right? Like remember the definition? The absolute value of x. It's positive x, as long as that's positive, and it's negative x if x is negative. So here I'm just saying, let's pretend this is positive, solve that. And then here I'm saying, okay, take my absolute value, and it's equal to negative whatever, so negative whatever, okay? All right, you guys can get started on that. I'll be right back in a moment. Here we go. I'm just gonna go for it. I'm just gonna have the negative x on this side. So I'm gonna subtract 2x from both sides, I get negative x. I'm gonna subtract 3 from both sides, so I get negative 10, and I get x equal 10. And then we'll check. Kevin, did it work when you checked it?
The first one did, the second one did.
The x equal 10 works? Let's see, we get absolute value of 13. And then 2 times 10 is 20, minus 7 is 13, absolute value, yeah. We all agree the first one works?
Yep.
I didn't really show any work, but I did check it. This one, you can distribute the negative into the brackets. So the signs flip. So now I have negative 2x plus 7. I'm going to add 2x to both sides, so I get 3x. I'm going to subtract 3 from both sides, so I get 4. So now you get x equal 4/3. Well, that sucks, because I got to plug that in over here. So, okay, check. I know what sucks. I got absolute value of 4/3 plus, so 3 over is going to be 9/3. That has to equal absolute value of 2 times 4/3, so that's 8/3. Subtract 21/3. Perfect. So let's see, that's 13/3. Absolute value of that is 13/3. Absolute value of this one, what's 8 minus 21? Oh gosh. What is it? Negative 13. Yeah, so here you get negative 13/3, but then you do the absolute value of it, so you get positive 13/3. So Kevin, you led us astray.
I'm sorry.
You said the other one didn't work?
I didn't do the absolute value of negative 13.
Oh, okay. Did you have your work like this, or were you
Yeah,
sort of?
sure.
No, you did. Okay. Yeah, it's a little risky skipping steps, but today's a good day. We didn't make any mistakes, except for Kevin. Kevin, you made mistakes. It's okay, it happens. Oh yeah. All right. All right, we can do some quadratic ones too. I said we weren't going to do it today, but I lied. So we solved a bunch of linear equations. Solving the quadratic ones is exactly the same. It just might involve some factoring. Yes, sir.
The last one had 4 solutions.
Oh, did I miss some solutions?
Yeah.
Do the negative ones work too?
For the both sides, right?
Give me a second.
Because they have 3 more.
I didn't even look at my notes. So, what other solution do you think works?
Plus or minus 4x, x plus 3. Like same thing.
So what? No, sorry. What are you plugging in for x?
For
Like, I just want to know, what are you plugging in for x that we didn't do, just so we can check it.
so you have 2 modulus, right? Like 2 more. So
Yeah. So what would they be? What are the other 2 solutions?
check.
Okay, maybe we'll come back, because I don't think there are anymore. But if there are, then we'll have to go back. So we'll keep going, and then I'll check with you in a bit to see if you got anything. Okay, for sure. Okay, sorry. So for the quadratic ones, you might have to factor. You might have to factor. Okay, but otherwise their strategy is the same. So we're going to solve the positive version of it, and we're going to solve the negative version of it. Okay, and then you'll have to check. You can have. Remember when we graph the quadratic one, the maximum number of solutions you can usually have is 4. So you can have between 0 and 4 solutions. So keep that in mind when you're doing a quadratic one. You can expect anywhere between 0 and 4 solutions. So let's do this one. Alright. So positive version is just going to be x squared minus 10 equals positive 6. And then for the negative version, this is the side I'm picking. So that side's positive here. Now it's negative. Notice how I didn't need brackets because it's just a monomial, yeah? All right, let's get cracking. So add 10 to both sides over here. You get x squared equals 16. When I square root both sides, what do I need to remember here?
It's plus or minus.
Yeah. Take the principal and non-principal square root, so plus or minus 4. So there's two solutions there. We should check them. So I'm gonna check them. I'm gonna write check. I'm not gonna do a lot of writing. If I check x equal 4, I'm plugging in 4. So I'm getting 16 minus 10, which is 6. Absolute value of 6 is 6. If I plug in negative 4, well, I got negative 4 squared, so it becomes positive 16. So now it's exactly the same as this one, right? You just get 16 minus 10 is 6. Absolute value of 6 is 6. Both work. Remember, you gotta check them, right? So we've seen questions where solutions didn't work. You must check them. It's not obvious if they're gonna work or not. Okay? This one over here, add 10 to both sides. So now you get x squared equal 4. I'll square root both sides. Don't forget the plus or minus 2. Check. So check x equal 2, you get 4 minus 10, which is negative 6. Absolute value of negative 6 is 6. And then check negative 2. Same exact thing is going to happen. There's 4 solutions. Do we have any questions about that one? We'll try a little bit of a harder one. And then that's our last example, and we got some time. Is it just 12 o'clock?
No, it's 12.
Oh, okay.
Oh God, it was 12 o'clock.
We might have gotten distracted by that video that has 62,000 likes of me. It's a real thing.
I mean,
We can't get sidetracked right now. We have
probably
to.
the only one
No!
that they've ever seen, so they were fascinated.
Okay. Our strategy is going to remain the same. So we're going to drop the absolute value, solve it equal to positive 3, and then we'll do negative 3. These questions are can be sort of long. I already put a note here in this example, one of the quadratic equation factors, but the other one doesn't. I mean, you can expect that to maybe happen to you. In that case, you use the quadratic formula, right? You guys, that's your favorite formula. Anybody have it memorized yet?
X equals negative b plus or minus the square root of b squared plus 4ac over 2a. You know I do.
Good job.
Wow. Yeah, it's actually not that hard. It's actually not that hard.
Yeah.
It's like not a flex at all.
It's a flex. But good, it's a good flex. Okay, so let's get cracking. I'm going to do my best to show you all the work. So we got, can someone read, what was it? 2x squared.
Plus 7x minus 1.
Thank you very much. So there's the first one. I'm going to just check my notes really fast. Okay, this is the one that's going to factor, so we'll do it first. Okay, so what am I going to do here though? You got to set it equal to 0. Why? Because I have the x squared and the x term, so I know that if I'm going to solve this, I need to factor it, right? I can't just do the square root of both sides. So subtract 3 from both sides. Now you're solving that one. Looking for 2. I hope that didn't come through in the video. What time is that at?
38.
Say it again?
38.
38 minutes? Kevin, all we can hear is you being quiet. Okay, so what are my two numbers here? 1 and 8? Right, whenever those things are 1 apart, usually it's 1 and something. Or the numbers have to be, yeah. Does that work? Yeah, if I made it -1 and +8, we all agree? For decomposition? So I'm going to quickly decompose this. Okay, double check, make sure that middle term is still equaling positive 7x. If that's the case, we can go straight to decomposition. If you are still confused at this, you really need to come get some help from me or someone. So, what factors out of the first thing? First two numbers. So 2x. And when I do that, I get x plus 4 I need the same thing here, so I'm going to pull out a -1 and I get x plus 4. So two possible solutions, x equal 1/2 from this bracket, and x equal -4 from that bracket. Okay, and you have to go check them, so checking them sucks. Now I'm just going to be lazy because we're running out of time. Apparently, according to my notes, they both work. I don't see a check in here, but I'm assuming that I checked it. So let me know if that's not the case, but you'd have to check. But I'm more interested in doing the other side where we get the quadratic equation for a bit of review. Okay? So let's just do it down here because it's going to be, so is it 2x squared plus 7x, what was it, -3, plus 3? Anyone? Hello? What was the equation again?
2x squared plus 7x minus 1.
Oh, equals 3. But now we're doing the negative side, so we'll do -3, right? Okay, so we'll add 3 to both sides. Oh, no problem. Okay, and apparently this doesn't factor. So it's not obvious, you're gonna have to check 2 numbers that multiply to 4 but add to 7. So really quickly you'll be like, well, 1 and 4, 2 and 2, I'll never add to 7, right? So if that happens to you, you need to use the quadratic formula, right? So you need to make sure that everything's on the same side, and then you're going to go a equals 2, b equals 7, and c equals 2, and then you're going to go plug it into this beautiful equation. You want to list it off again, Kevin?
Negative. Oh, you already got it. And it's not going to be flexible.
There it is. Of course, you have your formula sheet, so you can almost grab it from there. And now just pop in the numbers. You get -7 plus or minus 7 squared, which is 49, minus 4 times 8. I'm just going to try to do some shortcuts. So 4 times 8 times c. So 4 times 2 times 2. So it's just 16, right? Over 2 times a, which is 4. You guys double check really fast.
I didn't want to interrupt your class.
Oh, we're recording too. But I have to tell you about, they posted that video of me getting taped to the wall on TikTok, the Asian version of it. Has 62,000 likes.
Just because he's one.
You're famous.
Yes. Okay, we're in the middle of the lesson. Can you just...
This is Romero. I waved him in. That's my bad. Sorry. Go around.
He should know better.
Oh no, he shouldn't.
You guys
Any
see
other
me?
person
You guys see me move the football player? He's tense.
He's on the party bus.
No, we're
He's on the party bus. Sorry, am I interrupting your class?
yeah. Well, I'm recording it.
It's only 5. Oh, you're recording it. Oh,
It goes on YouTube. I don't care. No, nobody watches these anyways.
Okay.
Like just
Well,
Kevin.
I'm just saying the party bus. It's not too late. It only costs $5. There's a rumor going around that it was like $20.
People are gonna think we're the weirdest school, like teachers inviting students on party buses. Do I have to edit this out now? Like,
BYOB.
I'll bring the jacket.
bring your BYOB, bring your own books. You know, you gotta study. All right. So what do we get here? Guys, do you think of it? What's this? Is this 33? Okay. And then you'd have to go get the decimal answers because that's not a perfect square and it's going to be a nightmare. Like, do you think I would do this to you guys?
Yes.
No, I would not. Not on a test. No. I mean, if this happened to you, you would certainly have a calculator, so it'd be on the calculator part. Like, I wouldn't expect you to have to go check something ridiculous, right? Okay? Alright, thanks for your attention. Sorry about the Gong Show video.